Hello there, this is Bukanya Sraj taking you into Chemistry Made Simple. In this video, we are looking at chemical equations. Some elements are not reactive, like neon, helium, argon, but others are more reactive. Potassium, sodium with water. The azidide undergo rapid oxidation, like you see in this video. Adenosine triphosphate also give out light. The chemical equation is a symbolic representation of chemical reaction in the form of symbols and formulas, wherein the reactants entities are given on the left-hand side and the products entities on the right-hand side. An arrow is put in between, showing the direction of the products. What we can say, if you give an example, how to identify products of a chemical reaction. If you look at potassium phosphate plus aluminum nitrate, giving us potassium nitrate and aluminum phosphate, whereby the outer react with the outer and then the inner react with the inner. Now you can see potassium with the nitrate and then the aluminum with the phosphate. If you look at magnesium nitrate plus sodium carbonate, magnesium with the carbonate giving magnesium carbonate, and then the sodium with the nitrate giving sodium nitrate. So the outer with the outer, inner with the inner. In general, AB plus CD, that gives you AD plus BC, because now A has gone with the D and then B with the C. If you look at the chemical reaction A plus B being reactants and C plus D being products, an arrow in between to give you the direction. The substances that are in the reactants on this side, I will give you the products on the other side. If you look at the arrow separating them. If we look at example of hydrogen plus oxygen, will give you water, which means hydrogen and oxygen are reactants, water is the product. So that means that if there is a condition of reaction, then we can be indicated above the arrow. For example, if it is used or pressure and so on and so forth. In this reaction where we are forming water, you see actually the atoms are not balancing because there are more atoms one side more than the other atoms of their side. So we need to balance up the equation. How do we balance the equations? Now to balance this equation, we shall need to count the atoms on the left-hand side and the atoms on the right-hand side. That means that we are only going to work on the coefficients and never would you ever work on the subscripts. Only work on the number in front of the letter, never on the number written as a subscript, if you are to balance up the equation very well. And we are going to look at some good examples of this and also write the general rules we shall follow in balancing up these equations. This example of sulfur reacting with oxygen in trying to balance up the equation. If you look at sulfur reacting with oxygen, sulfur will react with oxygen to give you sulfur dioxide. But now, you see, you write on the left-hand side sulfur and oxygen, then on the right-hand side also sulfur and oxygen. But on the left-hand side, we see there are 8 atoms of sulfur, and on the left-hand side still we see 2 atoms of oxygen. But on the right-hand side, we see only 1 atom of sulfur, and there are 2 atoms of oxygen. So what do? We need to fix this. How do we fix that? We first fix sulfur. So on the right-hand side, let's multiply 1 by 8. That we can get, and we are going to write 8 in front because we said you only use coefficients. When you multiply it in front, that means there Okay, so as we were saying that they are now becoming 16 atoms of oxygen when you multiply 8 on the right hand side. So that means 8 sulfur, 16 oxygen. So now they're not still balanced. The other side they were 2. So you have to also multiply 8 on the oxygen so that now they can become also 16. Now that equation will be balanced. If you try another example, the one we're talking about for water being formed. So hydrogen reacting with oxygen gives you water. So there are 2 atoms of hydrogen and there is 2 atoms of oxygen on the left hand side. And then there are going to be 2 atoms of hydrogen and 1 of oxygen on the right hand side. So what do? We need to make sure that we balance up oxygen because oxygen is just 1 here on the right hand side. So if you multiply 2 in front, that makes it 4 hydrogen and 2 oxygen. But now hydrogen will not be balancing on the other side. So that means also multiply 2 in front of hydrogen and you make them 4. So now you have them balanced because now you're having the same atoms on the left hand side and the same atoms on the right hand side. Recall we said only change the coefficient and never change the subscripts. So that's a good example we are showing there. We can also show more good examples. Example, if you look at those polyatomic molecules or ions, you find that the good example, if you look at calcium sulfate plus sodium nitrate. Remember we said the way you form the products. The calcium now is forming with the nitrate, giving calcium nitrate, and then sodium with sulfate, giving you sodium sodium nitrate. I mean sodium sulfate. So which means look at how many atoms of calcium you have on the right hand side. And now for the polyatomic ions, we are saying let us take the radical, the sulfate. It's 1 on the left hand side. And then the sulfate is on 1 on the right hand side. Nitrate is 1 on the left hand side. And here, there are 2 nitrates on the right hand side. So if you look at that, it should be a little bit easier to balance them up because now considering the radical polyatomic ion, it will be very easy for you to balance it than taking one atom as you see in this illustration. So as we have said, you only count the polyatomic ions as one item such that it becomes very easy to balance it up than when you look at the atoms that are involved. So we have looked at this in that respect, that now you can see that we have just only multiply the sodium by 2 if you are balancing it up. Now it means when you put 2 in front, the nitrates will become 2 also on the left hand side, and already there are 2 on the right hand side. So it means this equation is now going to be balanced. You can try another example where you're using the methane reacting with oxygen to give you carbon dioxide and water. So there is 1 atom of carbon, 4 of hydrogen, and 2 of oxygen on the left hand side. 1 of carbon, 2 of hydrogen, and 2 of oxygen, and I mean 3 of oxygen on the right hand side. So what do? We need to balance up. We can multiply the hydrogen on the right hand side by 2. That makes it 4. And that means also the oxygen is going to be added to 4 because now you're having 2. And then you go on the left hand side, also multiply oxygen by 2, and that gives you 4. So that one now is going to be also balanced. In balancing up equations, we need to consider this, and that will help us very much in balancing equations. One, we have said that you must look at the steps involved. 1, you look at first write the unbalanced equation of the reactants on the left and the products on the right. Then after writing the unbalanced equation, the next step, you count the atoms that are involved. And remember that with using the law of conservation of mass, the same number of atoms must be on both sides. So you can start balancing by counting the atoms in the reactants and atoms in the products. And then go ahead and look at the coefficients that are the ones that we are going to look at mainly, and never consider the subscripts as we have been talking about previously. So don't forget also to write the states of the reactants and the products. If it is a solid, below you can put S. If it's a gas, after it you put G. If it's aqueous, you put HU. If it's a liquid, you put L. That will describe the state it is in. So basically, those are the most important things. So if you look at this good example where we are trying to balance propane reacting with oxygen and see what the products are going to be. So if you have propane, to balance this up, look at the 3 atoms of carbon on the left-hand side, 8 atoms of hydrogen on the left-hand side, and 2 of oxygen. So on the right, you have 1 of carbon, 2 of hydrogen, and 3 of oxygen. So you can start by balancing up, and you try to multiply, let me say, the oxygen by, if you multiply oxygen by 5, it becomes 10. You see? If you multiply hydrogen by 4, it gives you 8. So you can try to look at that, balancing slowly by slowly. And then, so you have said start with carbon multiplied by 3, you get 3 of carbon, then next multiply hydrogen by 4, and then next you can multiply oxygen by 4. I mean by multiply the oxygen by 5. And then another good example is if you try to look at iron 3 oxide reacting with aluminium, you get iron plus aluminium oxide. So how many atoms of iron do we have? And then, so if you just put 2 in front of aluminium, you find that this equation will be balanced. If you look at another example, if it is sodium hydroxide reacting with sulfuric acid, to give you sodium sulfate plus water. So you can, so if you look at this other example, we are having 1 atom of sodium, we are having 5 of oxygen, and then 3 of hydrogen and 1 of sulfur on the left-hand side. And then you have 2 of sodium, 5 of oxygen, 2 of hydrogen, and 1 of sulfur. So if you count, they are not balancing. So what we need to do is if you multiply a 2 in front of the sodium, at least you see that this side will be somehow okay. So to balance it up, also multiply a 2 in front of the water, and you can see that now the equation will be balancing. We can try another example of potassium chlorate being heated, and we get potassium chloride and oxygen. So in this, you see there's 1 atom of potassium, there is 1 atom of chlorine, and 3 atoms of oxygen on the left-hand side. The right-hand side, we have 1 of potassium, we have 1 of chlorine, and we have 2 of oxygen. So to balance this up, we can put a 2 in front of the potassium chlorate. And that means that now we shall have got 2, and then 2 chlorine, 2 potassium, and 6 of oxygen. So which means there must be also put a 3 in front of oxygen. On the right hand side, we can also get a balanced 6 on the right hand side, and then put a 2 in front to balance up the potassium and the chloride. So thank you very much for tuning in. We shall get more videos, and then don't forget to subscribe and get more of chemistry made simple. We've looked at mainly so far the atomic structure, the periodic table, formation of ions, and then formation of the formulas, and then we have also looked at now the chemical equations. So we shall add on and look at the more concept in the videos that will follow. Thank you very much. Don't forget to subscribe for more videos, and really you can also inform other students to subscribe and get more ideas in this chemistry so it can be simplified for all of us. Thank you very much. Have a good time. Bye bye. Don't forget. Bye bye. Hello there, this is Bukanya Sraj taking you into Chemistry Made Simple. In this video, we are looking at chemical equations. Some elements are not reactive, like neon, helium, argon, but others are more reactive. Potassium, sodium with water. The azidide undergo rapid oxidation, like you see in this video. Adenosine triphosphate also give out light. The chemical equation is a symbolic representation of chemical reaction in the form of symbols and formulas, wherein the reactants entities are given on the left-hand side and the products entities on the right-hand side. An arrow is put in between showing the direction of the products.